Hi guys, welcome back. Let's continue from where we stopped. And in here we're gonna start from the tag 0 and see how to work on some few tags for this very video. All right. This very tag says this program will assign a random number to the variable n each time it is executed. Complete the source code in order to print whether the number stored in the variable n is positive or negative. Now you can find the source code here. So if you click here, it's actually going to take you to where the source code is found. Here's the source code. So you will have to copy it and then go to your terminal or wherever you want to be writing your C code. But for this video, I'm going to use my terminals to write. So first, let me cd into the C programs. That's where I'm going to be using for this video. And then I'm going to call this task 1. Note that you've been given the name, so don't use mine. Task 1. And then let me paste that code that we've copied here. All right, now let's go back again. Now, since we've gotten the code, the next thing here is the variable n will be stored a different value every time you run this program. You don't have to understand what srand, ran, and all this means for now. So don't worry about that. You don't need to panic about the code. And then the next one says the output of the program should be the number followed by, if the number is greater than 0, it's going to be positive. If it is 0, going to be 0, and if it is negative, it's going to be negative followed by a new line. All right, so the parameter simply means, if you look at this code, you would see that there is a place, there is a segment written, your code goes here. Now this is the place, so that means anything you want to write should be within this very place. So delete this, do not touch any other thing apart from that. All right. And then the first thing you need to do is to define your if statement. If, let's say that the value entered, n, it's actually greater than 0. Okay, if it is greater than 0, then what you will do is to print f. The first thing you will do is to get your variable, the value that will be printed. So that's %d, and then is positive. Okay, and you call the variable name n. All right, then terminate it. The next one, otherwise, else if your value of n is less than 0. Okay, what you simply do at this moment is to print f, and %d is negative, because any number that is less than 0 is going to be negative. And then you have to call the variable name. And the last one is else if your n is actually equal to 0. Okay, you print that your %d is 0. All right, n. All right, your code was supposed to end with a new line, so you have to include new line at every time it terminates the program. So there should be a new line here, there should be a new line here, there should be a new line here. All right, okay, I think that's all. So let's save the code and see if that works. Okay, so I'm gonna compile the code tax1.c. Okay, we have a problem here. Let's see what the problem means. Implicit declaration of function printf. Of course, anytime you're using this function printf, it's supposed to be found under what? The stdio header file. It is even written here, include this very header file. So let's go back there again and then correct that. Otherwise, it's not going to check. So we insert mode, then we go to the first line. You can put it anywhere. It doesn't matter whether it's the first, second, or third, just anywhere, as long as it includes the header file. Include stdio.h. All right, so let's try to run that again. WQ Let's play this terminal and then GCC again. And then that's okay, it's working now. So let's try to run that. All right. You can see that the first time we are running, that value is positive, and you can see that 10028 and the rest is positive. Let's run it again. Since it is SRAND, it's going to be changing the value at all times you run. So you can see this value is different from the first one we had. Let's try it again. If you can see something negative, still positive. Okay, now this negative number. So you can see that minus 3, 5, something, something, something is negative. So that's what you're expected to do in that very task. All right. So let me clear the screen and look at the second one. Okay, the second task here says the last digit. Now this program will assign a random number to the n. Each time it is executed, complete the source code in order to print the last digit of the number stored in the variable n. Now we can find the source code here. I'm sure it's still the same code, but if not, anything you see right here you can use. I don't want to go into that again. And then the value n will store a different value each time you run the program. You don't have to understand the SRAN, RAN, and everything, every concept that is found over there. And then the output of the program should be the last string followed by n, followed by the string is followed by all these parameters given here. Now, if you look at this place, this is how it's supposed to be. Like the last digit of this is 2 because it's 2 last digits and it's less than 6 and not 0. Okay, let's see how to we're going to take this one after the other in the program. That's the basic way to write programs. The first thing here is the last string of followed by n. So let's try to get those two first before we move into something else. I'm going to call this I'm going to move, or let's copy the first task, that was task 1, to task 2, since we are using the same code. All right, so if at least I have task 1, task 2, okay? So I'm going to VI into task 2 right now. Task 2.c. Okay. Then I'm going to take this one off. I'm going to take this one off here. Okay. Now, let's try to take it one after the other. The first one here says the output of the program should be the last digit of and then the number. So what we'll do there is, so to handle that, we will simply say printf, okay, the last digits, okay, let's check that, the last digits of, where you have the n, you're going to change that to %d. It's going to take the value, whatever value it's found here, it's going to take that value and write it right here. So the last value of followed by n. So if the last digit of n is greater than 5, the string should write the value and is greater than 5. You can see example here that we have last digit of a particular number is 2 and is less than 6 and not 0. Okay, so before we now go into that, there's something we need to do to check very well, and that is how to get the last value. Now that takes us to a little mathematics, okay? And how do we get the last value of a line? There are two ways to actually do it. You can loop through it, or since you've not actually gone to that level yet, let's try to do the later one. Now, any value divided by 10 will always give you the last remainder. For instance, if I have 54 and then divided by 10, you're going to be left with 4. That's as a remainder, because 54 goes into 10 how many times? 5 times. You are left with 4. So let's say, for instance, I have something like 3,000. Okay. Now, if you find the modulus of 3,000, it's gonna give you 0, because 3,000 goes into 10 how many times? That's 30 times or 300 times, and the remainder is always 0. But you have something like 301, and then or 3001 modulus 10. That means you will have 300 times remainder 1. So the last value will always be there. That's the way to get the last value. So to do that, we can simply try to maybe add another variable here. You may not need to do it, but I just want to add it. Let's call it L digit. That's last digit. So my last digit is gonna be my L underscore digit. It's simply going to be equal to n modulus 10 modulus 10. Okay, so what does this mean? It means that each time you run the value, maybe you have the value to be 500 or 502 here, it's going to take that value 502 and it's going to store here where you have the n. So now 502 modulus 10 means 50 times remainder 2. So your L digit will now have the value of 2. Okay, so I'm going to say here that the last digit of D, that's the value of n, which is right here, is going to be is last digit. So the last digit is going to take the format specifier of percentage %d. All right, so let me just stop there and see what happens to the program before we continue. You take programs bit by bit. So let me put here the first thing that you take is the n. After the n, it's going to print my last digit. All right, so let's run the program and see how this works first before we move into something else. So escape here, :w and q. Okay, let's try to compile that. tax2.c. Okay, we have to terminate that buried line. So let's VI into that. tax2.c edit e. Okay, then that's going to be this place. Okay, let's save that again. So let's try to compile again. GCC tax2.c. Okay, so it's compiled now. Let's try to run the program this time around. All right, you can see that the last digit of this value is -1 because of course this is a negative value, so it's going to be -1. Now we are done with that very line. We've been able to check for the last digit, and we've been able to check for if the number is the remainder of the number, the last digit of whatever number that was given in there. Now, the next condition here is if the last digit of n is greater than 5, the string and should be written in this format that the last digit of the number is 2 and is less than or whatever parameter comes in there. So now let's try to do that. If the last digit of n is greater than 5, the string, whatever the string was, the last digit of n followed by the number, and is greater than 5. So we need to inculcate this to our work. So let's VI again into the tax2.c to edit it. Now, what you're trying to do here is, okay, now since the last digit of 2, of course, this is the value that is printed. Let's assume it is 10, or the last digit of 102, depending on whatever the rand value produces, is, let's say, 2. Okay, we have to put this in a condition. Okay, and the condition is going to look something like this. If our last digit, this time around I'm going to use the last digit, if our last digit L underscore digit is, let's check it, is greater than 5. Okay, is greater than 5. Okay, you're going to print this and then you're going to append this. If it is greater than 5, you will print this, and at the end you will tell us and is greater than, let's see that, greater than 5. Okay, greater than 5. All right, of course at the end there should be a new line. Okay, so what this means here is that if the last value of this, any value that is printed here, is, let's say, 2 or whatever number that is going to be the remainder, and is greater than 5 from this condition here, so you should take this into consideration. All right, but what if it is not greater than 5? Let's look at the second condition. What if the value is 0? Okay, that means it's equal to 0. Okay, now so we have to write another condition here. Let's end this. Else if L last digit is equal to 0. Okay, at this point in time you're going to print F the same thing, last digit of modulus D is comma specifier D and is equal to 0. New line, comma, you're still gonna take in the N and then the last digit. Okay, now the third one here says if the last digit of N is less than 5 and not 0, the string is less than 6 and not 0. Okay, now look at this. Okay, this question here is a kind of tactical. Now look at this. If you say that your value is less than 6 and not 0, now as long as it is less than 6, it's going to always print this is less than 6, and that 0 will be overwritten. So let's look at that. If you actually bring that very problem, maybe like here, I have the first time it's going to check if it is greater than 5 and then print for me. The second time it's going to check if it is equal to 0. All right. And then the third time is going to check if it is less than 0. If you interchange it and probably try to check if it is less than 0 first before checking if it is greater than 0 or equal to 0, it's always going to be true, because so ensure that your 0 comes first before you implement your 6. Okay, so else if your L digit is less than 6, at this time around you're going to print F the last digits of modulus D is modulus D and is less than 6, not 0. Okay, not 0 slash N then L digits, then terminate. Okay, so let's see if this works or if we will need a little modification again. So let's just WQ and then try to compile that. Tax2.c. Okay, so let's run the program and see what happens. Okay, now of course the last digit here is 3 and is less than 6, not 0. Okay, that one works. So let's see again. Try to run again. And this one is 3, also the same thing. This one is -2. Okay, is less than 6, not 0. Okay, so it's actually correct. It's working. -6, the same thing. I'm gonna take that as the last one. Okay, 1 and it's less than 6, not 0. So that's the correct way to implement that very task. All right. Okay. The next task here says write a program that prints the alphabet in lowercase followed by a new line. Now there are conditions here that you can only use putchar function. Every other function like the putf, the puts, etc., the gets is forbidden. And all your code should be in the main function. You can only use putchar twice in your code. Now, remember that putchar is responsible to or in printing just a character at a time. All right. Let me call that one alphabets vi alphabets.c. Okay. Now, you've not been given any code here, so you're gonna write everything by yourself. All right. So of course, the first thing we need to do is to declare our preprocessor as include stdio.h. Okay. Now, after this, of course, you need to check for Betty. I'm not going to do that for you. You should know how to do that right now. You have to check for Betty. So for that, I'm just going to write and leave it that way. Put your documentation right here and then integer main, where your program actually starts. And then, okay. Now, how do you write a program that executes that function, what you've been told to do here? You can use the while statement, you can use the for loop statement. So I'm going to use while, or sorry, for loop while you use while. So for, first we need to declare, we're going to call it char because it's a character type. Let's say I'm going to call it alphabet. LAP is for my alphabet. So for ALP, it's equal to the first letter of the alphabet is always A, and semicolon, then alphabet ALP less than or equal to, the second one is Z, okay, right, and then ALP plus plus. Okay, that's gonna look through A to Z. All right, then you're gonna put char the value of ALP. The next one here is put char new line. When you're done with that, you print a new line. Okay, and then this is how new line is written, /n. Note you will use just a colon, not double quotes, because it's a single character. It will not take double quotes. All right, so it's integer, so I'm going to return a value. Let's call it 0. Okay, so let's see what that actually does for us. WQ, let's try to gcc alphabet.c. Okay, and then let's run the program. You can see we have A to Z. So let me explain the code again one more time. Alphabet.c. Okay, so what this does is, at the first time of iteration, it's going to print A. Now, since A is not actually up to Z, it's going to take the next one to print B. So it's going to take one character at a time while incrementing till it reaches Z. When it reaches Z, the for loop is terminated, and then the print line is printed. So we will have our A, B, C, D, E, F, G, D to Z, just like what you're seeing right here. Okay, then this very one says write a program that prints the alphabet in lowercase and then in uppercase followed by a new line. So that is actually simple. It's the same thing we're going to do. The first time we're going to use small letter A to loop through to small letter Z. When you're done, you're going to do the same thing again to loop through from capital letter A to small letter, capital letter Z. When you're done with that, you implement your new line. That's going to take like 3 put char functions. So you can see here you're only allowed to use put char for 3 times. The first one is for small letters. Second one is for capital letters. The third one is for the new line. So that is solved already. When I was having the alphabet soup, blah, 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 write a program that prints the alphabet in lowercase followed by new line. Okay, and then print all the letters except Q and E. Okay, that's let's just try to illustrate that. Let me try to illustrate that. But I'm not gonna use exactly this Q and E that have been specified. So I'm gonna use something else. Let's say now what you do here is I'm gonna bring in a condition. Okay, so you're gonna start printing all this for me. For if, now before you do this, ensure that you put your for loop in a block. If your for loop has only one function to print or to perform after the declaration of the for loop, you may not necessarily need to open the block. But if it is more than one, you must enclose them in a block. Otherwise, the remaining code will not be seen as a loop. Okay, so close this loop here, and then after this, I'm going to define a condition that if while you're printing ALP, it's equal to, let's say, C, or it's actually equal to ALP, it's maybe equal to, let's say, Y. Okay, it's equal to Y, or let me try add another one, or it's ALP it's equal to, let's say, 0. Okay, at this point, continue. All right, the continue statement is used to skip some specified values. Like now, when I say C, Y, and O, each time the program loops through the for statement and then finds out that there is a C in that very loop process, is will skip that very later and print another one. But now, since it's actually a string, don't forget that this is supposed to be enclosed with a colon. All right, so let's run the program and see what happens if we are correct or not. Okay, gcc alphabet.c. So let's try to run the program. Okay, we have A, B, C, D, E, F, G. Everything is still printed. I think there's a mistake somewhere, so let's try to figure that out. Okay, now look at this. When you say for alphabet is equal to A to Z, the first thing here is for you to print. Now, when the value is A, Putcha will print a false before checking for this condition. Okay, so that means that it has already printed the value before checking for the condition. So I think you're supposed to check for the condition first. If the condition does not meet what you're targeting, it should print. But otherwise it meets, it should jump and pass. If I should use that statement, jump and pass. Okay, so let's take this one out of here. Let me just comment it off without wasting much time, so I can simply do this. But don't try it. Betty will give you code check error. So let me run this again, wq, and gcc alphabet.c. Okay, let's run that out. Okay, you can now see you have A, B, C is not there, D, E, and you can see O is not there, and then Y is not there. So that's how to implement that problem. All right, so you have to take note that you must ensure that you run the condition first. It must first check for the conditions. Where the condition is not met, it will try to print the values that you asked the compiler to print for you. Okay, so let's move ahead to the next one. Here it says numbers. Write a program that prints all single numbers in base 10, starting from 0 to 9, because base 10 starts from 0 to 9. All right, 10 is not it's a base 10 value, but it's actually iterative. Base 10 starts from 0 and ends at 9. Others are just iterations. Okay, so I'm sure you can do this using your printf statements. I try to do this yourself. It's very simple. Just declare a for loop for let's say I equal to 0, and then I less than or equal to 9, I plus plus, then prints format specifier %d. Then you put in the variable you declared for your I. It's gonna solve that issue. Okay, now the next one is actually the similar thing, but in a different context. Write a program that prints all single digit numbers of base 10, the same thing, followed by a new line. You are only allowed to use Putcha That's one. You're not allowed to use the char variable, data type, and then you're not allowed to use printf and put in this aspect. Okay, let me try to explain that because I know it's a bit technical. Let's go out of this place, create another file. So let's clear this and create another file. Let's call it vi numbers.c. Okay. And then you open the block. Okay. Now, since you're not asked to allow to use char, you're going to use int, of course. Int, let's call it I. Or I can choose to call it number. Let's just call it number. No. Okay. Now, what you're going to do is you're going to be printing those values using the putchar. But putchar, it's a function that takes only characters. So it's not going to take your numeric data type. Okay. So if probably I do something like this, let's say for number equal to 0, and then number less than or equal to 9. Okay. Number plus plus now let's say putchar number. Okay, and then I close it there. Putchar, I'm gonna close this. So I'm gonna have something like putchar again for my line break. So this is gonna be /n. Okay. Now that's fine. But if I try to print this, let's see what happens. Colon WQ and save. Let's compile that. It's gonna compile number.c. Then we try to run that. Now you can see that it's printing empty spaces. It's just completely empty spaces because it does not recognize that value as a character type. It is not a character type. It's actually an integer type. But assuming I declared a character, that's char, as a data type, it's of course gonna print the 0 to 9 for me. That's why Alex said do not use char, because they're trying to restrict you from using the simple process to something technical. And for you to do that, you'll simply, okay, and you're not gonna print those numbers, but you're gonna cast each of those numbers that will be printed to its equivalent ASCII value by using :0. That will take you to it will cast those values that you're trying to print to its equivalent ASCII value, and that's when the putchar will recognize that value. Now if I run this again, let's see what happens. WQ, let me compile again, number.c, then try to run /a out. Okay, you can now see we have 0 to 9. So that's the way you can typecast that value to ASCII variables, hence to or ASCII value, so that your putchar will see those numeric values as a character data type, and hence you'll be able to print your numeric values on the screen. All right. Next one here is write a program that prints the lowercase in reverse, followed by a new line. All right. Now I'm not going to do this, but let me just give you an highlight of what to do. Remember that we've printed the value from A to Z, okay? And then each time we print the A, it increments. Let me just use something to illustrate that. Okay, let me vi. I'm still gonna use the same number.c to illustrate that. Now, instead of printing from 0 to 9, I'm gonna print from 9 to 0. So here it's gonna start from the value 9. It's gonna start from the value 9, and then it will decrement. So by that, I'm gonna use greater than, because value of 9, that means the next value will be greater than or equal to 0, because we're going to start from 9 through 0, like we are coming down. So that means at the first time the value is 9, and then if 9 is, the second one is number greater than or equal to 0, that means is 0 greater than or equal to 9? No. So it's going to increment, or it's going to decrement. At this point, instead of using incremental, we're going to use decremental, such that the first time is 9. Now it checks for the condition. Is the number which is 0 greater than or equals to 9? Of course no, so it will decrement. So the next one is going to be 8. The next condition is it up to 0? No, the next condition is going to be what? 7. So like that, it will progress till when it gets to 0, so that the condition becomes, is 0 greater than 0? No. Instead, it's the same thing. That means the program is going to hold there and then move out of the for loop statement. So if I run this, let's see what happens. GCC number.c, and let me try to run that. You can see we have 9, 8. It's now decrementing the other way around. So you can use this trick to sort yourself out with the task given right here. So we move ahead. Okay. Write a program that prints all numbers of the base 16 in lowercase followed by a new line. You're only allowed to use putchar, and at the end it should print a new line. Okay, we have only 3 putchar to be used in this code. Fine. Now, what is hexadecimal values? It starts from 0 to 9, right? After 9 you have A to F. So that's very easy. You just need to look through 0 to 9. When you're done with 0 to 9, you look through A to F. So that's 2 putchar, and then the third putchar is gonna give you the new line. So we have A through 9, 0 through 9 right here, and then we have A to F. I think that's pretty simple. It's just equivalent to what we had right here, A to Z, and where is that place? I think in the yeah, this tax 3 where you have A to Z, small letters, and capital A to Z, right? So that's pretty simple. Then the last one for the mandatory task says write a program that prints all positive combinations of single digits. Numbers must be separated by comma followed by a space, and the number should be printed in ascending order. You can only use putchar functions, and put is not allowed. All your code should be in the main functions, and this is how the format will look like: A or 0, 1, 2, 3, all right. So the first thing you do is to see how to write 0 to 9 and with the commas and space. Let's start with that one first. I'm going to treat just 0 to 5 so you can complete the rest. All right, so let me clean this off. Let's lay this out, and let's call this bi let's say special, that's ace num dot c. I'm calling it special number dot c. All right, and then your preprocessor directive, I include stdio.h. all right, and your Betty, don't always forget this. I'm not going to do that. Okay, integer main. Okay. Now you're asked to print 0 to 5 according to my own description. So integer, let's say I. Let me use I now. So we can say for, you can choose to use while loop, or I've been using for too much. Let me use while loop for this very video, or this very task rather. While I, okay, is less than or equal to 5, because that's where I'm going to stop. Now, if you are using a while loop, you must initialize your value. This should be equal to 0. Very, very important. If you don't initialize, it's not going to give you a correct output. So while I is greater than or equal to 5, what you do is open a block first, you will put char, try to print it out. Put char, of course, you know what to do, but you have to cast this to the ASCII code for that. And then you have to increment I plus plus, okay? So now you've been able to print the value of 0 to 5, okay? But you still need to add the comma and the space, so you have to use put char, okay? And I will use the comma here, put char comma, and then when you're done with the comma, you put char again, because it takes one character at a time. You can't use both at the same time. So I'm gonna say put char space, okay? So first, let's see how that works first before we go into something else. Return 0. Okay, so let's see if this works before we try to edit the code, because I know there will be a little issue right here. So let's run this first. gcc snum.c. Okay, we have an error. We need to terminate that very put char line 12. Okay, so let's VR again into the file, and then let's go to the line 12. And terminate this. Okay, so let's try to recompile that. Sorry about that. It's not capital letters. It's WQ. So let's recompile it. Okay. Let's try to run the program. Now we have 0, comma. Of course, we've gotten what we wanted, but there's a problem. Now, if you look at this work given to you, the last value is not supposed to be to have a comma and a space. All right. So you have to write a condition that will check if the value reaches the end of the character. Don't add your minus, or don't add your comma and your space. Okay. So that's the next thing you need to work with. So let's try to implement that. Okay. So what you will simply do here, it's there are many ways to implement that, but I can simply say that my I should be less than 5. Since I know that 5 is the last value, I'm going to say my I should be less than 5. So you repeat those things. When you're done with it, okay, I'm going to print the last one, put char, and then I will call it 5. Okay. Now, it may not be the best method. There are other methods. You can use the if statement to actually declare when your I is equal to the last value. If your I equals to 5, then do a particular thing. But this is another method to actually solve that problem. I think this one is more easy to implement. So let's compile that again. gcc snum, and then let's try to run that again. So a.out. Now you can see that we have 0, 1, 2, 3, 4, 5, but we're not supposed to have 2, 5 here. So let's try to correct that quickly. s.num. I don't know why that happens. Okay, I think I removed this before now, but I had network issues, so it's returned to my previous where I edited last. Okay, so let's try to add new line. So put char. Okay, so let's save this now, and then compile again. gcc as this, and then a.out. Now you can see we have 0, 1, 2, 3, 4, 5, and the last number does not have a space nor a semicolon. But before you try to do what I've just done, you have to confirm if you've been given maximum limit. You can see that you can only use 4 times maximum in your code. All right. Now, if you vi into this file, now you can see that we have 1, 2, 3, 4, 5. Okay. So you're not supposed to use this very type, this very way. You're going to use another method such that you don't exceed the number of pucha you're supposed to use. So let's see how to do that. Let's take this one off. Now, before you print, okay, before you make your printing start from 0, you have to check some conditions. So the condition is going to look like if my value in I is equal to 5, because that's the last value I'm expecting. If it is equal to 5, then put this value like that. But if it is actually not equal to 5, you have to increment it and then add your pucha comma and then the space. Or you no, I don't think that's not gonna work. So what you simply have to do here is this. The first thing you will do is to try and print the values. So take off this one from here. Is to print the values. All right. So while trying to print the values, you check for the condition. So when you print the first value, it's going to check for a condition that if the I is actually equal to the value 5, okay, then the program have to stop there. Okay, you have to break out of the loop. But if the condition does not reach 5, then print comma and then print space. Let me explain the logic again. While I is less than 5, print the value of 0, 1, 2, 3, 4, 5. Okay, print 0 first and then increment it. Now, if you increment it and then it's up to 5, break. But if it is not up to 5, you have to I think no, the increment is supposed to be at the end. So let's take it off from here and then take it to the end. Okay, so you try to check for the condition. If it is not equal to 5, you have to put a comma and then put a space, increment it again, check. If it is not equal to 5, continue doing the same thing, but once it is up to 5, don't continue the incrementation, break out of the loop. All right, so let's see if this works. WQ, and now you can see that you have 1, 2, 3, 4 pucha, and I think we've met our criteria. So let's compile again. A.out. Okay, we have 0, 1, 2, 3, 4. It's not actually printing the last value of 5. That's because we've omitted something, VIS. And what we omitted is that I forgot to add my while to be equal to 5 also. So the number stops at 4. So let's add that equal to 5, and that will solve our problem. Okay, so let's see if that works now. WQ. So let's compile again, snum. All right, then let's run the program. Okay, you can see we have 0, 1, 2, 3, 4, 5. So I think in your own case, you're supposed to iterate till you reach 9. All right, this is actually advanced task, so I am not gonna do that. Try to walk yourself through to do this. If you understand what you've done so far, like very well, or at least to some extent, I'm very sure that from task 10 down is not going to be that difficult for you to try. Okay, Thank you for actually having me around here, and I'm happy to be your host. Bye for now. Bye bye.